Hey all, it's Miss Gross. Welcome to Lesson 6, Scaling an Area. Our learning target today is I can describe how the area of a scaled copy is related to the area of the original figure and the scale factor that was used. Before we get started, make sure that you have Lesson 6 in your red notebook, and we'll go ahead and get started when you're ready. Okay, we're going to go comparing areas. So we have these two rectangles, and we've got to figure out the scale factor. And as you can see on the screen, the scale factor is 3. And the reason why the scale factor is 3 is because 2 times 3 is 6 and 4 times 3 is 12. So that's why the scale factor would be 3. Remember, scale factor is multiplicative, means you would multiply the original figure by a number to get the scaled figure. So now we got to figure out what the area is of this. This area, 2 by 4, is 8, because 2 times 4 is 8. And then this area, 6 times 12, is 72. Now, if you notice, the scale factor is 3. 2 times 3 is 6, 4 times 3 is 12. But 8 times 3 is 24, not 72. So, the area of the copy changes the scale factor by the scale factor squared. Because what we're doing is we're multiplying the scale factor by 3, and then we're multiplying it by 3 again. So 3 times 3 is 9. And that makes sense because 8 times 9 would be 72. So the area of the copy would be 9 times the area of the original, because it's the scale factor times the scale factor again, or the scale factor squared. Write this down. Make sure you pause the video if you need more time to write before we move on. Now we're going to move on to scaling areas. So again, we have this same copy, 2 by 4 and 6 by 12. And we know the original area is 8 units. And we know the scaled copy is 72 units, as we learned the last time. And so we could split this up. If you look at it this way, you can split this into your rectangles. This is 3 times. So you could fit 3 of the original copy here. And then you can do the same thing as you're going 3 this way. 1, 2, 3, 1, 2, 3. And then 3 by 3 is 9. So that's another way of looking at it. The original area is the scale factor squared, 3 by 3. And so your example here would be 8 times 3 squared, which would be 8 times 3 times 3, which is 9, and 8 times 9 is 72. I hope that kind of helped if you were a little bit confused. We're going to do one more example. May draws a rectangle with an area of 20 square units. She wants to create a scaled copy of the rectangle using a scale factor of 5. So go ahead and write that 20 units squared and the 5 in there. If the scale factor is 5, then how many times larger would it be? Now remember, we have to do the scale factor squared. So what we would need to do is we would need to do 5 times 5. So in this particular case, it would be 25 times larger, okay? And then the area of the scaled copy would be how many units? Well, we would need to, after we got that 25 in there, we would need to multiply the 20 by the 25, and 20 times 25 would be 500 units. All right, so let's break it all down. We learned that lengths are one-dimensional. In a scaled copy, they change the scale factor. So 2 times 3 is 6, 4 times 3 is 12. So lengths are just the one dimension because it's length or width, right? It's just one dimension. But area is two-dimensional, so it changes the scale factor times it. So you would do, if you were, just like we said, if it was the scale factor was 3, then the area would be 9 because it's 3 times 3. If the scale factor would be 4, the area would be 16 times bigger because 4 times 4 is 16. The scale factor is 6. Again, 6 times 6 is 36. The area would be 36 times bigger. I hope this video helps you. Let me know if you have any questions. Have a great rest of your day.